PET, or polyethylene terephthalate, is used for making most plastic bottles. Functional need. PET is tough and durable, lightweight, and transportable, food safe, impermeable to water, and it is ideal for storing drinks that require high pressure, as well as those that do not. Aesthetics. PET bottles can be blow molded into different bottle forms. They display the name of the product well, and they are transparent and can be colored to make them attractive to the eye. Cost. PET bottles are cheap to make because of the mechanized nature of the blow molding process, which keeps costs down. Although blow molding keeps costs down, in many cases, a PET bottle costs more than the drink they contain. Environmental cost. PET bottles are recyclable, but many end up in landfill, and there is a high environmental cost because they contaminate water supplies as they release a substance known as leachate. Oceanic pollution leads to massive rubbish zones in oceans around the world. Plastic bottles and their tops are the third and fourth most collected plastics from the ocean. Availability. PET is available as granules, pellets, flakes, sheets. Ethical factors. Polyethylene terephthalate bottles should be recycled to prevent oceanic pollution and leachate from landfill. PET bottles are made from crude oil, a finite resource that isn't likely to last for future generations. Social factors. Consumers use PET bottles for leisure and hydration. Bottled water is a modern phenomenon which is socially accepted. Cultural factors. Polyethylene terephthalate bottles have created a convenience mindset. The food and drink industry has been changed. Glass bottles are used less because they have been replaced by PET bottles. Polypropylene, or PP, is a thermoforming plastic that can be used to make food containers. Functional need. Polypropylene is durable, tough and robust. It maintains food quality, and it is impermeable to water. It is a good insulator of heat, and it is resistant to chemicals. Polypropylene resists bending and doesn't fatigue and break. Aesthetics. PP can be rough or smooth. It can be transparent or frosted. Color can be added to give it an attractive look. Cost. PP is cheap to manufacture. Environmental cost. PP can be recycled, but if disposed of in a landfill, it can produce leachate, which leaks into water supplies causing damage to habitats and stunting the growth of wildlife. It can end up in the oceans causing pollution if it isn't recycled or reused. Availability. PP is available in sheet, granule, pellets, powder and different sections of tubing. Ethical factors. Disposal of polypropylene adds to landfill. It is made from crude oil, which is a finite resource, and may not be available to future generations if it isn't managed. Social factors. PP is accepted socially as a food-safe polymer for storing food. Cultural factors. Unfortunately, using polypropylene contributes to the throwaway mindset. Functional need. The selection of materials to make toys such as the robot and toy digger are wide and varied, but when it comes to selecting polymers, thermoforms are used. High-impact polystyrene, also known as HIPS, is a popular choice. It is tough, hard and rigid. It has good impact properties, and it is lightweight. Aesthetics. High-impact polystyrene is colorful, and pigments can be added. HIPS can be smooth or textured. It can be glossy, or have a matte finish. Cost. HIPS is made from crude oil, which involves many processes before it is used to make a toy. This makes the initial cost higher than a timber-based toy. Toys made from polymers such as HIPS are cheap to make, especially when they are mass-produced. Bulk buying reduces the cost of the polymer. Environmental cost. High-impact polystyrene is recyclable, and so it lessens the impact on the environment. A large amount of thermoforms are thrown away into landfill. This includes HIPs. Disposal of HIPs can add to oceanic pollution. Availability. HIPs is available in many forms including powder and pellets. Ethical factors. The use of HIPs leaves less crude oil for future generations. Cultural factors. Character merchandising and mascots from films and sports events are possible because of the use of polymers such as HIPs. Breakfast cereal companies use free toys and collectible items to entice young consumers to be repeat buyers and to create brand loyalty. Social factors. Consumers are used to toys being made from polymers, such as high-impact polystyrene. Phenol formaldehyde, or PF, is a thermosetting polymer that is used for electrical and heat-insulating applications, such as handles for kitchen utensils like pots, pans, and electrical plugs. Functional needs. Phenol formaldehyde, or PF, is hard, heat and chemically resistant, and has good electrical resistance. Aesthetics. PF has a matte or gloss finish. It can be smooth to touch or rough. PF has limited colors and is usually black. Cost. It is cost-effective and cheap to buy because it lasts a long time. Environmental cost. Thermosets are hard to recycle, but the environmental cost is less because most phenol formaldehyde products last a long time. PF is biodegradable, and so at the end of life, products with PF components can be broken down through this process. Availability. PF is available as a resin and in the form of glue or adhesives. Ethical factors. PF is a thermoset that is sourced from crude oil, which is unsustainable. Because thermosets have a longer life cycle, this fact reduces the impact on the environment. Social and cultural factors. It is accepted that cookware uses thermoset handles. Urea formaldehyde, or UF, is a thermoset polymer that is used as a resin for preserving dead animals and plants. But it can be used to make electrical fittings such as wall sockets and switches, buttons and handles. Functional needs. Hard, stiff, excellent heat resistance and an outstanding electrical insulator. Aesthetics. UF is very smooth, glossy in appearance and is white in color. Cost. UF can be injection molded. So, the high mechanization of the process reduces the costs. Bulk buying UF reduces the cost to the manufacturer. These cost savings are passed on to consumers. Environmental costs. UF lasts a long time in landfill. It is hard to recycle. Availability. UF is supplied in granular forms ready for compression and injection molding. It can also be obtained as an adhesive or glue. Ethical factors. UF is sourced from crude oil, which can pollute the environment, and it is a finite resource. Thermosets last a long time, and so this reduces the negative impact on the environment. Social and cultural factors. Historically, it is accepted in modern societies that UF is used to make electrical fittings.